Up next, StarTalk Special Edition. I've got Chuck Nice, I've got Gary O'Reilly, and our geek in chief, Charles Liu, to help us decode some of the deepest questions asked by our Patreon members, including, for example, are there any questions that astrophysicists think about that we don't have an answer to yet? Well, what's up with that? Also, are the extraterrestrials having conversations with each other? Can we decode it? Is there some special encryption that they're using that we will never know how to break into it? We're going to learn about that. Also, a little bit about quantum field theory. What is it? Why does it matter? Coming up on StarTalk. This is StarTalk Special Edition. We got Chuck Nice. Chuck?
Yes. Hey.
What's up, Neil? Gary O'Reilly?
Hi, Neil.
All right. And we're doing Cosmic Queries grab bag. And I think I'm okay with a grab bag, but generally we need bigger guns than that. So we went into the silo, typed in the launch codes, and out came Charles Liu. How you doing, dude?
Hi, Neil. Hi, everybody.
Excellent. Welcome back to StarTalk.
Thank you.
You know, I'm unworthy. I can get him.
Not at all.
Get him near the edge. You could take us off the edge and take us into orbit, and that's what we need you for in these situations. We got questions from our Patreon members. So this is grab bag. So what do you guys have? What did you bring to the table today?
All right, let me jump in first. Thomas Cochran from Kansas City. Are we thinking about the fundamental/basic components of the universe incorrectly? Perhaps the universe's most basic building blocks are fields instead of particles. What merit does quantum field theory have? And there's already a thank you tagged on the end.
Oh, that's so nice. Well, the bottom line is you're both right, whether you're thinking in particles or in fields. In fact, quantum field theory is in fact trying to knit together quantum mechanics, special relativity, and classical field theory. Right? Field theory is what? It's pretty straightforward. We, as particles, interact with fields, such as a gravitational potential field of the Earth or some electromagnetic field, something like that. So different kinds of objects, depending on their properties, interact in different ways with different fields. Now, if you think instead that we, as particles, are actually not static things, solid things or whatever, but are rather waves or fields, but in sort of strange, unusual concept, then you can just mathematically express every particle in our bodies as a field interacting with a larger field or with other kinds of fields, maybe the Higgs field, the thing that provides mass. So we're not looking at it wrong so much as we're looking at it in an incomplete fashion. One of the big things about the universe, right, Neil, is that we still can't knit general relativity and quantum mechanics together. So people are using different approaches to try to get at the same answer. And it's totally okay if you're not able to address everything with your theory, as long as somebody else is addressing the other stuff with another theory. Maybe we can bring them all together.
Yeah, I would add a nuance to that it's not that there are fields and there are particles and never the twain may meet. It is the very interaction of fields and particles that is the universe. That is that is the operations of the universe. So one of those would not be more fundamental than the other when they need each other to manifest the universe as we have come to know and love. Now, we might say something else. We might say, is there something more fundamental than both the field and the particle? And Charles, would string theorists jump into this at this point?
They might claim.
Yeah, they want to claim that.
If the claim is that a particle is just a manifestation in our space-time of what we see of a more complex object, then the interactions of strings, to some extent, might either supplant or supersede interactions between fields or interactions between particles.
Right. So that would be a deeper understanding, but we're not choosing particles versus fields, right? No, they're both working together very nicely.
That's right.
Worlds are colliding. Cats and dogs are sleeping together.
Yeah, that does happen.
That is a Bible verse, isn't it? That's one of the signs of the apocalypse, right? So who's next up?
How about Brandon
Cortazar. Look at that. And Brandon says, hello, Neil. Hello, Charles. This is Brandon from Scranton, PA. My question to
nice
both
town.
of you.
Hi, Brandon from Scranton.
Yeah. Say hello to the people at Dunder Mifflin. My question to you both is, what is the one thing that is currently unknown in the science and astronomy world that you wish to find the answer to before your time on this earth comes to an end?
Ooh.
Oh,
Mm.
why so
ominous with
Yeah.
the way that I had no other choice
you
but
changed
to be.
that voice to make it sound like to an end.
The words required him to say it exactly the way he
They
did.
did, you know. I mean, we are speaking of your ultimate demise.
Whoa.
No, Chuck, it's your ultimate demise. You know, it doesn't weigh the same. I guess.
Right,
Okay.
exactly.
Well, Neil, you have one? I
wanna
think
go
I know
second.
one. I got
I'm gonna
lots.
go
You want to go
second
second? Okay. The one I want to know, I would like to know, is does life exist outside of our solar system, outside of our Earth, that's based on DNA? I imagine, based on all the scientific knowledge, there is life out there. And when people ask me, do you think there are aliens? I say yes. But the question is, would we recognize them if we see them? Would they have developed the same way that we did? So my question is pretty specific because Brandon asked about being scientific, right? I got to narrow it down instead of just saying, is there alien life? But is there alien life based on DNA? That's what I want.
How Prometheus of you.
It is. It is. But wait, Charles, what you really mean is not is it based on DNA? You have the broader question is, because that's just a yes, no. The question is, if there is alien life, on what system of chemistry does it base its identity? Be it DNA or anything else.
Sure.
That
would be the extension of my question.
Yeah.
Yes.
Yeah. Okay.
Right, but if it is based on the DNA which we find in all human life in all life on this planet, life on this planet, okay, we share that DNA, then that would mean most likely that we came from someplace else.
It could mean that, but it wouldn't have to. I'll tell you why.
That wouldn't have to.
A common ancestor.
But it'd be a very likely scenario that we came.
No. All you have to
someplace
do is look at the strand, look deep in the strand of DNA, see if it matches anything here. If
right.
it doesn't match anything, it's a complete separate
completely
genesis.
separate. Right.
Correct.
Right. But if there are markers that match, that means that we share something that's out there.
And Charles, isn't it true in Star Trek that they finally fessed up that
Season 7, Star Trek: The Next Generation, the episode called The Chase.
Damn,
yes.
That's crazy.
That's
Jean-Luc
why he's
Picard's old anthropology professor figures out that there's something really cool, but unfortunately he dies before he can find the answers. So Picard takes the Enterprise all around, and they find out indeed that the reason all the Klingons and all the Romulans and all the Vulcans and all the humans have 2 arms, 2 legs, and 1 head is because they share a common genetic
ancestor.
Yeah,
right.
It is.
But okay, so we don't
Picard,
share that common
what is this? Your first race war? Come on.
So what if this isn't a DNA commonality here, and you end up with Fermi's paradox, and we're looking, where are they all?
Mm-hmm.
That we're just not looking in the right way. They've turned up and they're all gas based. And
and this is why I think that Neil's extension of my question makes sense. If we are wise enough or insightful enough to look for life in ways that we don't have it here on Earth, we may find it much more quickly than we think. Or you can take sort of the Edward Snowden idea and think that any intelligent species out there will do its best to hide its presence from anybody else so as to protect their privacy.
Oh, they're shy. Okay.
Yes.
And there's a Star Trek Next Generation episode about that too, where the Enterprise goes into an environment for a bunch of very shy aliens. And they usually find a way to sort of push anyone who comes in away. But the Enterprise is too good. They show up, and so they wind up having to interact with the aliens, and then they have to...
Well, there's one where they literally push the Enterprise away with a repulsor beam as they approach the planet. But all right.
Well, actually, there's a branch of the military that concerns itself with this. There's an interesting phenomenon. So if I send you a signal and you decode it, I don't want you to decode it, right? So the fact that you know it's a signal is because it looks different from everything else that you're otherwise coming to your detector.
Okay.
So what I want to do is encode it so that you can't figure out what's in it. And the perfect encoding of my signal is where when you receive the signal, it looks completely like noise. Because if there's any lingering structure to it, then you hand it over to the cryptographers, and then they decode the structure and they'll find the message within it. The argument then is the most sophisticated forms of communication will be indistinguishable from noise.
From just
and the
noise.
Civilization will just disappear into the din of the background, and you will never know what anybody's saying ever again. That's a limiting case of encrypted messaging. Just so I put it out there.
Just blast it with a bunch of static. Why waste your time doing that?
Well, because your signal would still be visible within it, unless your signal was encrypted to look like static. Correct.
Mm-hmm.
Yeah, it is.
Wow.
So my answer to that question is, I want to know if it's a two-part question. I want to know if we are smart enough to even answer the questions we have posed. Or better yet,
damn,
are we smart enough to even know what questions to ask?
Right.
I want the answers to those two questions.
We're still asking them, aren't we?
But isn't this where AI comes in, Neil? Where we set it up to ask for the things that we haven't thought to ask for, to look for the things we haven't yet thought to look for.
Okay, that'd be great. We put it to work immediately, because I can tell you this: a chimp will not know to ask, can the rotation rate of Earth slow because an earthquake changed the moment of inertia of the rotating sphere?
Not even Bubbles could ask that.
I
think Bubbles would ask that.
Neil. I mean,
but just think,
probably
that's a question
not, but
that is so removed that they don't even know that's a question. So I want to know, are there those kinds of questions we could be asking about the universe, and we're not even there yet? And even if we're there, will we know to ask the question? That's the question I want answered.
Let's ask Bubbles a chimp.
All right, next question. Keep it coming.
Those are great answers. Go ahead,
All right,
Gary.
We've got Bill Wessel, or Wessale. There's a number of ways you can pronounce this. He's from
There's
Texas
probably
Hill Country.
only one, I'm betting.
I know, but he even admits we'll probably get it wrong.
Okay.
Since time travel causes mass to disappear in one space-time and appear in another, wouldn't that require a mass to energy conversion in the original space-time and an energy to mass conversion in the destination? And wouldn't that essentially be a huge nuclear bomb, or reverse?
Okay. Well, let me see if I understand the question correctly. I'm going to answer.
I was about to say,
yeah,
I don't get what he's asking.
I'm going to answer the question.
And before you answer, Charles, so Gary, look me in the eye, okay? Repeat after me. Nuclear.
Nuclear.
Thank you. Not nuclear.
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 Thank you for the correction.
Nuclear. You're not George W. Bush.
Oh,
okay.
man.
Nuclear.
Thank you for that. Thank you for that distinction.
Okay. On this show, it's nuclear. Okay, go. Charles.
Okay.
Damn.
So to avoid a nuclear explosion, the way that we would solve this problem is
that's the worst kind.
Much appreciated.
That's the worst kind
Gary,
of explosion.
you pronounce nuclear however you want. You'll still be part of the nuclear family of StarTalk.
Okay.
Hilarious.
All right, here's the story. I'm assuming that what the question is asking him is time travel backwards and in a large jump, like say from here now to Jurassic times or to the sinking of a Titanic or something like that, right? Because we are always moving through time anyway. When I am here and then an hour from now, I move down the street, to get an ice cream cone or something like that. Then what will happen is that I have just moved in space and time, right? And there was no nuclear explosion. So the question I think is being asked is there a scenario where if you're moving not the way we ordinarily move through space-time, would that cause a contradiction and some sort of huge energy release because mass has been displaced and there's E equals mc squared, things like that? And the answer...
Are you sure the question isn't really your mass changes as you move fast? So are you getting that mass from some other place? Is that getting converted out of some form of energy or vice versa?
That could be the question too.
Maybe.
That
I don't
could be
know.
the question too.
I'm not sure.
So anyway,
I'm not sure.
yeah, the bottom line is it's a great question, but we're not exactly sure what the answer is because there are ways to interpret that question. Bottom line is I would say that generally speaking, time travel forwards, which was what we do, and occasionally backwards, like what antimatter particles do, does not necessarily have to cause an E equals mc squared like release of energy. You can do it in other ways.
Charles, did you just say antimatter moves backwards in time? You just said that, didn't you?
I did say that you could think of antimatter as backwards traveling matter.
Okay. He's doing the Enrico Fermi thing on us here.
Am I correct? No, correct me if I'm wrong.
You're correct. Yeah, you're correct. You're correct.
Okay.
It was discovered, part of the discovery thinking that led to the prediction for antimatter was antimatter would be indistinguishable from regular matter, but moving backwards through time. And then they figured, well, everything's moving forward to time, so maybe it's a new kind of matter called antimatter. So that's how that came about. Okay, give me some more.
This is Anthropocosmic Dylan. He says, Neil, in Cosmic Queries, you make the distinction between intelligence and life. Other than the common ways we transmit messages like radio and light, could we be bombarded with measurable or tangible transmissions and just not know it? Thanks, Dylan from San Diego.
Yeah, that relates to what we just said a moment ago.
We just said that.
Yes,
yeah.
it did.
Yeah,
We just talked about that.
If the civilization wants to be noticed, their signal should look different from the background noise of the universe. Otherwise, how could they expect us to pick it up?
Right.
I would assume they're smart enough to arrive at that conclusion. But if they wanted to talk about us without us knowing, which would be the alien equivalent of pig Latin in front of children, okay, or some, or some, way that you do that, they would, as we said earlier, they would encode their message. You need a key, and with that key, it would be able to decode complete noise into the signal that you put there. But the real issue, because there's an issue here. The real issue is, how did they get the key in the first place? How do you send them
on
the
the
key?
EK?
Yeah, I'm going to say the key is pig Latin. Wouldn't it be funny if they just sent us a message in pig Latin? Ow yay, are yay, ooh yay.
Or ubby dubby. Ubby dubby.
Or ubby
There's a
dubby.
great one. Bye-bye,
So,
folks.
Neil, do we need AI to build us a 21st century Enigma machine?
Yes. And we'll get back to that when we return from this first break in StarTalk Special Edition. We'll be right back. We're back, StarTalk Segment 2, Special Edition, with our geek in chief, Charles Liu. Because, like I said, we pull him out of the silo, the garage.
I do not wait in a silo for you, by the way. I hang out on my 4-poster feather bed in my top-level resort, hanging out, taking it easy.
He is our intercontinental geek missile waiting to be launched from our silo.
Exactly. Exactly.
Hang out with the corn and wheat.
So, what kind of question? Oh, so Gary, you threw in AI at the end there. I think AI will do things that we don't know how to do. We can't figure out how to do. By the way, Charles and I, as astrophysicists, have been invoking the brilliance of computers from the beginning, and not just doing rote tasks, but have it do tasks where it's going to discover stuff that we would glaze over if we had to review that much data, or just find things that are weird or wacky. So now we can get it to try to decode or to invent a code that could be sent. Sure. AI, we don't fear AI the way everybody else is right now.
That's right.
Okay. Well, it's
So
not
you
in
guys-
charge.
I don't wanna
just-
You guys are going to destroy us all. I see. I see how it works.
I already
But
know
Charles-
the name of our robot overlords.
Yeah, but Charles, I don't want to speak for you, but I think we've been using the powers of computer ever from the beginning. And all of a sudden, a computer can now compose your term paper and everyone loses their shit. because it
Well-
stepped into the world of the liberal arts?
Those term papers are like C+, B- at best. I wouldn't. worry
I'd
about
agree.
it.
If you really,
If
you
you
really
look at
no, they may get better.
In my most recent final exam, I had for my students the following question. Type the following question into an artificial intelligence language generator, and now tell me what the answer is wrong about.
Interesting. So you trick these people into using AI. They're like, damn, this guy won't even let us cheat.
It's a
guy's-
matter of them understanding what you need to know today, right? If we can't be better than some free app you can get on the internet, then what is your value to an organization or to a graduate
anything.
program or to a company, right? So you should learn how to use them, see their weaknesses, and use your education and your thought processes to make you more valuable. And that's how we must move forward in all of education. If we teach people exactly the same way we
should
did
be that all the
in the
time.
19th century, which unfortunately a lot of times we do, especially with math and science, right? What are we giving them? What is the advantage that they're getting from their education?
Wait, Chuck, Gary, I think Charles Liu is the overlord.
I'm going to say.
So keep
You're a
going. What else?
class A
Who's
Eddie.
next?
All
up?
right. Okay,
Who's
next
teed up
up,
next?
Nathan Hill, right? Nathan Hill's from Austin, Texas, and he did go to your Cosmic Perspective talk as well as the Q&A when you were down there, Neil.
I was there. Yes.
Yeah,
I mean, I gave
so-
the talk. Yes.
Right. My question is regarding gravitons. If gravity is an effect of mass warping space-time, where does the need for a graviton fit into the relativistic model?
Ooh. I'll give my
When
best
Einstein-
answer. You
What?
fix it up, okay?
Go
So if
for
you have a piece of mass sitting there in space, there's the distortion of space and time. Okay, there it is. It's the fabric responding to the existence of the mass. Now you poke the mass. You either collide two black holes, you jiggle it, you shake and bake it, and a ripple gets sent. That ripple moves at the speed of light, and the quantum analog to that ripple is a graviton moving at the speed of light. And so, but the fabric shape itself is not the graviton. That's my understanding of this, Charles.
I think you've said it exactly correct. Another way to think about it is the following. The graviton is a particle that's been proposed but never been detected. And the reason it was proposed is because we want to try to fit gravity into quantum physics, right? The theory of relativity that Einstein came up with did not have in it this idea that you had to have a particle transmitting gravity. But once we built quantum theory and quantum field theory and all those kinds of things, and we got the sense that in order for any one particle to interact with any other particle, a third particle has to mediate the transfer of something between those two.
This is the field
And
theory. part
That's
of it,
right.
yeah.
And so people said, well, if gravity is indeed a field that generates force, then there must be a particle that transmits that force. Let's call it the graviton. But it doesn't fit well in the current standard model of particle physics. In fact, you don't need the graviton to do any of those things with quarks and fermions and bosons and all those kinds of neat things. So at the moment, gravitons remain a mystery, and they're a placeholder for some more sophisticated physical theories that we don't have yet that will link quantum mechanics with general relativity.
We have nonetheless detected gravitational waves.
Yes.
So that's a Nobel Prize all
Right.
around for that.
That's right.
And so, yeah,
Numerous people do think that the gravitational waves are essentially an indirect confirmation of the existence of gravitons.
yeah,
but-
yeah,
I don't know.
yeah, yeah.
So basically,
right.
what you're saying is we've rebuilt the engine and we've got this other stuff left on the side. But we
Some
know
nuts
it's
and bolts.
important somewhere, but we can't quite work out where it has to go in the
Yeah.
thing.
Then you start
Okay,
the engine
fine.
and then your car blows up and you know, oops, that should have gone
Yeah, but
there.
oddly,
Yeah.
that doesn't happen. That's the weird
Yeah,
thing about
I
it.
know.
Right.
Everybody I know who's rebuilt an engine. There's always some parts.
Yeah.
They're
It's the universe's equivalent of an IKEA like furniture.
That's right. Why do I
don't know
have
what-
this extra Allen wrench?
Yeah,
What the
what is
heck?
that?
Yeah.
Why is all this stuff left over? But
Yeah.
you know, it works. The chair works.
It works. It works.
It
Mhm.
works. All right. Yes.
go.
This is Johnny, and that's all he says. But Johnny says, Hello, Charles. Hello, Neil. In a prior episode, Neil mentioned that Hawking radiation process occurs due to the intense gravitational energy directly around the event horizon. Is it really because of the curvature that it's so intense that it manifests into actual energy, or is it just the energy of stuff it's sucking in? I have always thought that gravity was just merely potential energy, and then he signs it Bill Bailey. So, Johnny is Bill Bailey, apparently.
Won't you come home, Bill Bailey? Won't you come home?
Look at you.
That's a song.
That's a song.
That's a
It
song.
That's a song, baby.
Yeah.
That's a song.
So there's a lot to unpack in that question.
Yeah.
So
he
let me
asked
hand
an
it to you,
awful
Charles.
Yeah.
So tell us
Yeah.
the difference between just the gravitational field and what we think of as gravitational energy, and then
Right.
energy density. Just unpack all
Right.
that for
Wow.
us.
It gets a little bit in the weeds, but fundamentally, if you have a field and you have a particle in that field that interacts
Uh-oh.
with the field, there's a
Okay.
little bit of energy. When you move that particle in the field, it feels a force and some sort of energy gets released. Depending on where you are in the field, the amount of energy released varies, hence the concept of energy density.
Mhm.
Over here, you're going to have more energy per cubic centimeter or
Volume, yeah. Mhm.
something like that. Over there, you have fewer. Okay. So when you're talking about Hawking radiation in a black hole, there's actually a lot that still needs to be straightened out. All right. What Hawking was doing a quantum / thermodynamic argument about any object that's in the universe that's compact and it's got some sort of event horizon. Okay. But really, you can take those equations and extend them, and you can say that pretty much anything pretty much anything emits something along the lines of Hawking radiation. It's just that for black holes, it's actually important because that amount of emission is the only stuff that's coming away from the event horizon of the black hole, right? The rest of the stuff is all outside the event horizon that's doing any kind of emission of energy. So that's why Hawking radiation is cool. At the moment, we don't know if it's because of some sort of say effect that you have antimatter-matter pairs near the event horizon. And we don't know if it's quantum tunneling. We don't know if it's just some sort of basic thermodynamic effect that happens in all cases. So there's still mystery there. So you put your finger on a good question that yet needs to be answered.
Did I tell you what Brian Greene told me recently? I had lunch with him. Brian Greene up the street here at Columbia University.
The Elegant Universe guy.
Author of The Elegant Universe and several other books to follow.
Yeah.
So he told me that there's emergent thinking that this vacuum energy of virtual particles that pop in and out of existence, and these particles are matter and antimatter pairs that energy creates, and then they re-find each other, and then they become energy again, which is a vacuum version of what Hawking radiation is right outside of a black hole. He was suggesting that when they are created and separated, they're quantum entangled.
Yes.
And while they are quantum entangled, the actual connection between them is a wormhole, which is how you can have information move basically instantly. Okay.
Right.
Or the state be resolved instantly because it's an actual wormhole. And what he said was that the very stitches of space-time might be this myriad network of wormholes created by virtual particles coming in and out of existence.
Wow.
So it's not just metaphor that the space-time is a fabric. It's like it is a fabric, and the wormholes is the material that weaves the fabric of space and time. That freaked me out. I had indigestion.
It's very cool.
That's really cool, man.
Yeah.
That's
The virtual particles
really
wink
cool.
in and out of existence in tiny fractions of a second. So they have to keep replenishing themselves all the time if that's the fabric of space-time. Otherwise, the fabric of space-time just falls apart like a tapestry that's been hanging for too long.
Oh,
Oh, dear.
oh dear.
A renovation in the castle.
The castle.
I must say.
It's the end of this guy's question, the end of Johnny's question. He says, And I always thought gravity was merely potential energy.
Right.
But surely that can't be the case in space because there's no up, no down.
Right.
It's not like I
Gravity-
could take it up so as it drops down and I've got potential energy.
Gravity is not potential energy, but
you.
gravity, if you have a particle that's in a gravitational field and that particle has mass, it contains gravitational potential energy, which can
Right.
then be released if it falls through the system.
But
And
just
in
to be
that case,
clear,
it's
if
not
the
a matter of
particle's
going,
not there, if the particle's not there, we still use the phrase it's a gravitational potential. Okay, potential well. You put the particle here, then it has gravitational potential energy. So I just want to finish that
Right.
thought.
You're
Yeah.
exactly right.
Gotcha.
And
Right.
so
Mhm.
in space, we don't worry about up or down, Gary, as you rightly say.
Yeah.
We worry about whether it's in or out.
Or out. Right.
If it's close to or away from
Yes.
some sort
There it
of
is.
gravitational center.
Exactly.
Yeah.
Cool.
All good.
Wow.
All good. Slip one more in before our second break.
All
Okay.
right. Brian Ridge doesn't say where he's from. Instead of dark energy within the known universe, is there a chance something beyond is sucking to cause the expansion of the universe from beyond? If it was traveling away at the speed of light, we would never witness it. Right? Question mark.
Oh yeah. So Charles, does the universe suck?
Hey.
The universe does not suck.
Okay,
Actually.
thank you.
Okay.
And neither do black holes, but that's another conversation.
I was going to say which universe doesn't suck. 'cause
But thank you.
there's-
That's the other universe sucking.
there's so many of them, Charles. I mean, come on.
That's true. Now, in
But
order
the question
for
is whether another universe is
Right.
creating this anti-gravity suction.
Right, is somehow causing the expansion.
Right.
In order for that to happen, there are two assumptions you can make, and it depends, right? Assumption number one is, if that were the case, then that means that our observable universe is just a little bubble in a much larger universe, and something around the outside can therefore create that kind of expansion through suction, right? But that hasn't been confirmed yet. There are ideas, for example, something called eternal inflation, which suggests that might be a way that multiverse is created. But there's nothing that we know of in terms of the mechanics of the cosmology that we understand that could cause that in that scenario. The other situation might be that if we, as a four-dimensional space-time, were embedded in a five-dimensional membrane, then that fifth dimension, and not talking, Motown,
right.
but that fifth dimension, well, then you could imagine, although we, again, haven't figured out anything physical yet that could be this, you could imagine that our four-dimensional thing is expanding in the fifth dimensional thing almost because of something, say, a surface tension, in the same way that, say, an oil slick expands across
the
pond,
surface of the water.
right, surface of
Right.
the water when
And
the
it
water's deeper.
just keeps expanding no matter what.
That's right. And so
Yeah.
you have a situation where we're trying to figure out the mathematical aspects of how you might connect four-dimensional space-times within five-dimensional membranes. But there's nothing physical yet that allows that to happen.
So now,
the answer, I guess, to the question is stay tuned.
Okay. yeah, okay.
So
Okay,
if it's surface tension, Charles, could we not use that to travel? Like a pond skater across the surface of
Well,
a pond?
if it is some kind of surface tension, that would be an awesome way to travel in the fifth dimension.
There you go.
And
But
then you
is it a
could
tension?
violate this faster than light.
Right. But that's
you could
because you're
easily do
not.
that.
Yes, but that's because you're not in our four-dimensional space-time anymore.
Right.
The laws of speed limits and physics or whatever, mass, etc., could be completely different. Which is,
Right.
for example, one of the tenets of something called Randall-Sundrum theory, where
Okay,
Dr.
say it-
Randall
say
and
it-
Dr.
wait.
Randall-Sundrum theory.
Okay.
Okay. Barbara Sundrum and Lisa Randall.
All right.
They came up with this idea some years ago, suggesting that if indeed our space-time were connected to other four-dimensional space-time via membranes, that might explain things like why gravity is so much weaker on same distance scales as the nuclear force, right? Why is that the case? These are the things that we don't know yet, but they're being thought about, and that's kind of
Gravity
fun.
is embarrassingly weak.
Right.
To all the rest of this. Yeah.
Well, yes, gravity is ridiculously weak, but because it can extend over long distances, and because it does not have a negative that cancels out the positive, gravity in the universe on cosmic scales has no equal.
Yeah.
I may be weak, but I'll beat your ass any day. Come on with it. What you want to do? I
Yeah, that is the exact voice Gravity would have, I'm sure.
Try me. You know who I am. You all know I'm Gravity.
We got to take a break.
Yeah.
We'll come back for segment 3 of StarTalk Special Edition when we return. We're back for the third and final segment of StarTalk Special Edition. We got Cosmic Queries going here with Chuck Nice. And we got Gary Riley and our geek in chief, Charles Liu. So
intercontinental ballistic.
we opened up the silo with the right launch codes, and out came Charles Liu. Because he, however geeky I am, he goes beyond.
I'm happy
Raining
to
down
deliver.
a veritable hellfire of knowledge upon you all.
I will gladly deliver whatever payload I can.
There you go. All right, so
Nice.
who's teed up next?
Okay, let's jump straight in. Joe Stamps, that's with an S. If you move backwards from a giant ticking clock at the speed of light, what does it do? Stop ticking because of the relativity or because the light from the next second can never reach you? Thanks for all you do and respect from me and my family who keep looking up.
Oh, excellent.
Oh, that's so cool. Yeah. Well, yeah, the answer is actually they're both right. Relativity allows you to think of time and space in different ways because they are relative to one another. They behave differently. So you do not see that clock tick because you are moving away from it at the speed of light. And so the sound or the information from the tick never reaches you. It will still tick in its own stationary frame of reference, but you will never know that it ever happened. So in that sense, you could say the clock ticks, but it doesn't tick for you.
Now,
Ask
if
not
there's
for whom the clock ticks. It
but
ticks
for whom the
you.
clock tolls. Yeah, okay. So, right, but if there's another clock that you're headed towards,
Right.
then you would see that clock go faster because you're catching up with every next
That's right.
tick, correct?
That's right. That's right. So it's the direction
it's
you're
the frame
traveling
of reference.
and the speed. It's all about frame.
Yeah, okay.
Frame of reference. That's what makes the whole thing work.
Nice. All right,
That's
let's keep
super
going.
Cool. Okay, how about Alexandria French? She says, my husband and I listen while we cook dinner every night.
Nice. What are you cooking?
Oh.
What you cooking?
And thanks for sending
Maybe
us
French
some.
cooking.
No, I know,
Yeah.
right.
Yeah, exactly.
It's French food.
Yeah.
It's French cooking. Yeah.
Okay.
Yes, we'll have a little coquille Saint-Jacques. We'll take it. Let's see. She says, I have a burning question that came from I came from Patreon to ask if we could put a telescope.
But the question burns. There's an ointment for that, I think.
Oh, Jesus Christ.
Hope it doesn't burn while you're cooking. Don't burn your
There you
food.
go.
Yeah,
Don't burn your food.
Okay. If we could put a telescope on a galaxy, say 15 million light years away, would the depth of the observable universe change based on the changing the point of the observation?
love it.
Thank you.
Well, the answer, Alexandria and husband, I would say is that no, it does not change. 15 million light years away, Alexandria, is actually the center of that spot's observable universe. 15 million, 15 billion, wherever you are away from us, that is the center of the observable universe at that point. You see, we are living in a universe that expanded from a single point, which means that you can't actually point to one spot in our current universe and say that one is the center, any more than you can point to any other place and say it's the center. So every spot in the universe is expanding away from every other spot. And therefore, we have an infinite number of centers of observable universes because every single spot is a center in its own observable universe.
But Charles, I got to add, if there's a galaxy at the edge of the universe, which is on the edge of our observable universe, and we go there, that galaxy will see just as far on the other side of its location, and it'll see half the universe that we cannot see.
Correct.
Because
So
it's in the center of its own horizon. So the question was, what will they see relative to us? If you go to the horizon, they'll see parts of the universe we can't see, but they
That
still
will
think they're in the middle of the known universe. Right.
Yes, that's
It's like being out in the middle of the ocean and spotting an island. You're like, land ho, but from on the other side of that island, they may be looking out at stuff that you won't be able to see as you look at that island.
If the island was on your horizon,
If
right?
the island was
right.
on your horizon, yes.
Right. Okay.
That's
I think that's where that was coming from, I think.
Sounds good. Yeah.
Okay. Gary, what do you got?
All right, Christopher Scott's next up. Given that energy is neither created nor destroyed, does this mean that all of the fossil fuels that are in the ground as forms of stored energy have been around for eons already? If so, are we simply redistributing the location of the energy on our tiny little rock in space? We are not actually adding any more energy to the system, just moving where it is.
Can I answer this? Can I answer?
Oh, please do.
Yeah.
Double get with it. Okay.
Mhm, go ahead.
Okay. You ready? Okay.
Mhm.
So first of all, energy can be destroyed by turning it into matter. Okay. So the concept of energy can neither be created or destroyed was modified after E equals mc squared, and it's the sum of energy and matter that cannot be created or destroyed. It's the sum of those two. Okay. So now the fossil fuels are solar energy.
Mhm.
All those life forms got their energy from the sun. If they were plant life, they got it directly. If they were animal life, they got it because they ate the plants that got the sunlight. So fossil fuels is solar power, except that it's polluting the air and we're not going to be able to reproduce it because all that energy has been sitting there for us for millions of years. It's been buried energy. Once we use it and it radiates out into space, it goes back into the universe. It's not still here on Earth. Charles, you take it over from there.
What else can I add? What a beautiful explanation.
You
Completely
can
correct,
add the
too.
fact that the energy that it is creating is a perturbation of the atmospheric conditions that create global warming. And
that is a great thing to
creates
add.
more energy, or actually intensifies energy, and it's going to
Interesting part of that cycle.
It's going to destroy us all.
Yeah.
We trap more sunlight. Yeah,
We
that's-
trap
Yeah,
more
become-
sunlight.
Becomes
Wait.
a giant magnifying glass.
Releasing the solar energy, precisely, Gary. Releasing the solar energy that was stored in these microorganisms, which were turned into coal and oil and natural gas, or whatever these fossil fuels are, also releases at the same time how it got bound down underneath the earth, which in this case is carbon. And the carbon comes out in the form of carbon dioxide, and it is adding something new to our atmosphere that we haven't seen in hundreds of thousands of years. So the answer is that if you define the system as the universe, including the sun and deep down in the earth and out in space, the energy has not been created or
Good
destroyed.
point.
It's been redistributed.
Right.
But if you're thinking about the system as our Earth's atmosphere, our biosphere, the environment that humans live in, oh yes, we are injecting a lot
of energy.
We are adding a huge amount, and it's not just a balance change, it's an actual increase. And by all the different features that everybody here has said so far. So yes,
and of course, the
making
difference is the original source of energy was the sun. It came to Earth, was stored and locked underground. Now we have re-released that energy. Where after we've created civilization on a stable, relatively stable climate, and now we are altering the climate by re-releasing this Pandora's box of energy. Well, primarily because of the byproduct of it, which is the burning of fossil fuels, which is where you get your CO2.
There you go.
Yeah.
There you go.
Guys, we got time for one more question. Give it to me.
Go ahead, Gary.
All right. Okay. Gavin Bamber from North Vancouver says, please visit. Maybe, maybe not. We'll see.
Sure.
I ask, what is the largest object in the universe?
The universe.
Whoa.
The universe itself.
The universe.
Okay. No, that's a lot.
I'm guessing Gavin was looking for a slightly different
How
answer.
come we are so unified in that ridiculous joke? I know we've said that too many times.
It depends.
No.
I think it depends what they mean by object. Like,
Right.
are we an object? So there are
Great point.
forces that hold together our
Right.
molecules, but you can separate the molecules.
Right.
So what is the object, you or the molecules?
Right.
Is the galaxy an object?
Right.
Even though it's composed of things that were stars and planets.
Right.
So on that scale, what would you say, Charles?
Well, if I were to say that an object is defined as something that is being held together
Good.
in some recognizable way by some kind of force.
I go with that.
Okay. Then the largest objects are these superclusters of galaxies out in space. They contain huge amounts of matter. Our Milky Way, you guys know, has about hundreds of billions of stars in it.
Yeah.
Right. But these superclusters contain thousands, sometimes hundreds of thousands of galaxies. And so you add all that together, and then there's all that cosmological dark matter in between them. And so you've got a huge chunk of material that all is bound together by gravity. So that would probably be
if it's bound together, we think of that as a coherent object.
Yeah.
In that sense. The cluster as an object. Yes.
Right. What makes it work?
Gravity, man.
It's still got the gravity.
It's me, man. Gravity. Who you messing with? What you want to do?
Okay, so an illustrator is going to come hear us and then have gravity, personify gravity. It's going to be Chuck's voice. All right, that's all we got here. Guys, thanks for doing this once again. StarTalk Special Edition. Neil deGrasse Tyson here. Keep looking up.